So in today's video, we're going to be talking about the measure of dispersion, and the measure of dispersion in statistics actually helps us to get the spread of our data set, and this is the reason why we call the measure of dispersion the measure of spread also. So we can either call it the measure of dispersion or we can call it the measure of spread. The measure of dispersion consists of the mean absolute deviation, it consists of the variance, it has the standard deviation, and it also have the range. So these are the four basic tools we have when it comes to the measure of dispersion or the measure of spread of our data set. So let's start with the concept of the mean absolute deviation with this question we have here. So our question says that Michael is interested in knowing how much his friend spends on average in a day. He decides to ask each of them how much they spend and gets the following data set. We have 12, we have 15, we have 17, we have 14, we have 10, we have 11, we have 13, and we have 15. So the question now says we should find the mean absolute deviation of this data set. So the first step is for us to write the mean absolute deviation formula for this data set of ours, and as we can see that this data set is in the ungrouped manner, that is, it is actually in its raw form. So the formula for the mean absolute deviation, also known as M.A.D in short, is going to be summation. We have a modulus sign, we have xi minus x bar, we close the modulus, divided by n. So where our xi represents the value of the individual variables present in our data set, we're talking about 12, 15, 17, 14, 10, 11, 13, 15, and x bar represents the mean of the data set, and n represents the size of our data set. We have two vertical lines which act as the absolute sign or the modulus sign, and that simply implies that any negative value we have in this data set, by subtracting the mean from the individual variables, is going to be a positive value. That is, we can never have a negative value when subtracting in this case, because we have a modulus sign. So that being said, the first step in getting the mean absolute deviation is for us to get the value of the mean. So the value of the mean, which is our x bar in this case of ours, is going to be equals to summation x divided by n, and that is basically the sum of all the variables we have divided by the size of our data set. So counting on our data set, we can see that we have 8 of them. So that means we can say that our n is actually equals to 8. So let's sum. We have 12 plus 15 plus 17 plus 14 plus 10 plus 11 plus 13 plus 15, all divided by 8. So when we do the maths, 12 plus 15 plus 17 plus 14 plus 10 plus 11 plus 13 plus 15 actually gives us 107 divided by 8. And if we do the math, 107 divided by 8, that gives us 13.38 approximated to 2 decimal place. So the value of the mean of our data set is actually equals to 13.38. So it's time for us to substitute the necessary details into the formula to get the value of the mean absolute deviation. So I'm just going to write M.A.D right here is actually equals to, so I write the modulus sign. So we start with 12. So we have 12 minus 13.38. We close the modulus sign, plus we have 15 minus 13.38. We close the modulus sign, plus 17 minus 13.3, minus 13.38, and we do the rest. Everything right here divided by 8. So we have the mean absolute deviation to be equals to, so 12 minus 13.38, that is actually equals to minus 1.38, but because we have the modulus sign, so it's going to be 1.38 plus, so 15 minus 13.38, that is 1.62. So the essence of the modulus sign is that any value that is negative becomes positive, and any positive value remains positive. Plus, so 17 minus 13.68, and that is 3.62, plus 14 minus 13.68, that is 0.62, plus 10 minus 13.38, that is minus 3.38. So with the modulus sign, we have this to be 3.38 plus 11 minus 13.38, and that is minus 2.38, which is going to be 2.38. 13 minus 13.38, that is minus 0.38, which still turns out to be 0.38. So we have plus 0.38, and then we have 15 minus 13.38, and that is plus 1.62. Everything right here divided by 8. So let's sum everything we have in the numerator. So we have 1.38 plus 1.62 plus 3.62 plus 0.62 plus 3.38 plus 2.38 plus 0.38 and plus 1.62, and that gives us 15. So 15 divided by 8 is actually equals to 1.88 approximated to 2 decimal place. So the mean absolute deviation of our data set is actually equals to 1.88. So let's go to the next question. So our question says that in a class, a midterm test was conducted and the result of the test is given below. So we have 11, we have 17, we have 12, 15, down to 20. So the question says we should construct a frequency table for this data set and also find the mean absolute deviation of our data set. So before we actually construct the frequency table, we need to know the formula for the mean absolute deviation also. So we have the mean absolute deviation formula right here is going to be equals to summation f xi minus x bar modulus divided by summation f. So in this case of ours, we are going to be in our frequency distribution, rather, we are going to be considering the expression xi minus x bar. We are also going to be considering the modulus of xi minus x bar, and then f times the modulus of xi minus x bar. So let's get our frequency distribution. So we have the horizontal line right here, excuse me. So let's draw the horizontal line. So it's going to be a long line. Then we have the vertical line. So we have this one of the lines right here. Then we have one of the lines right here. We have another one. So let's get the frequency distribution for our data set. We've actually done this when we're trying to use the same data sets to get the median and the mode of the data set. So getting the frequency distribution is not hard. So we have our x right here, we have our frequency right here, we have a 10, we have 11, so the first step is for us to get the mean of our data set, and the mean of this group data set x bar is actually equals to summation fx divided by summation f. So that means we need to get a space for fx. So fx is actually the product of the variable with its corresponding frequency. So 10 times 3, we have that to be 30. 11 times 4, we have that to be equals to 44. 12 times 1, we have that to be equals to 12. 13 times 4, we have that to be equals to 52, and we do the rest. So let's sum the fx. So that is going to be 30 plus 44 plus 12 plus 52 plus 14 plus 75 plus 16 plus 34 plus 54 plus 38 plus 60, and that is going to give us 429 divided by, let's sum the frequency. That's going to be equals to 3 plus 4 plus 1 plus 4 plus 1 plus 5 plus 1 plus 2 plus 3 plus 2 plus 3, and that gives us 29. So the value of our mean is going to be equals to 429 divided by 29, and that gives us 14.79. So the mean of our data set is actually equals to 14.79. So all we have to do is to have the space that says modulus of xi minus x bar. So that means we are going to be subtracting the mean from the individual variables, and the modulus sign simply implies that any negative value we have gets down to a positive value. So let's start with 10. So 10 minus 14.79, 10 minus 14.79, that is minus 4.79, but because we have a modulus sign, minus 4.79 becomes 4.79. The next is 11 minus 14.79, and that gives us minus 3.79. But because of the modulus sign, we have a 3.79. So let's work with 12. So this is it's going to be 2.79. 13, that's going to be 1.79. 14, that's going to be 0.79. 15, that's going to be 0.21. 16, that's going to be 1.21. 17, that is going to be 2.21. 18, that is 3.21. 19, that is 4.21, and 20, we have that to be 5.21. So the next step is to multiply the frequency with the modulus of the difference between the variables and the sample mean. Please note that this expression right here, xi minus x bar modulus, is also known as the deviation. We call it the deviation, so we should just pay attention to that. And because of the fact that we have a modulus sign next to this deviation, it simply implies that the deviations can never take a negative value. So let's write this here. So we have f into bracket xi minus x bar. So let's multiply the frequency with the modulus of deviations. So we have a 3 times 4.79, that gives us 14.37. 4 times 3.79, we have this to be equals to 15.16. 1 times 2.79, we have this to be 2.79. So the next step is for us to sum everything we have right here, that is the sum of the products of the frequency with the absolutes of the deviation. So we have 14.37 plus 15.16 plus 2.79 plus 7.16 plus 0.79 plus 1.05 plus 1.21 plus 4.42 plus 9.63 plus 8.42 plus 15.63, and that gives us 80.63. So let's come down a bit. So the formula for the mean absolute deviation is actually going to be equals to 80.63 divided by 29, and when we do that, that gives us that's 80.63 divided by 29, and that gives us 2.78. So the mean absolute deviation of our data set is actually equals to 2.78, approximated to 2 decimal places rather. So let's solve the next question. So our next question says that the management of a gym is interested in knowing the age distribution of people that visit the gym. So for this, the management decides to look into the ages of people who registered for the next 6 months. So below is a frequency distribution of the age. So we are supposed to find the mean absolute deviation of those distribution. So the formula for the mean absolute deviation, where we have our grouped data in this format sorted based on class, is a summation f, the modulus of xmi minus x bar, close the modulus, divided by summation f. And if we take a closer look, we are going to realize that this formula is not different from the one we used in the previous question, and that is because the only difference right here is xmi, which represents the middle class of individual classes. So all we have to do right now is to try to extract out those details and reconstruct the table. So we have the horizontal line right here, so we just draw this way. And then we have I think 6 vertical lines. I don't know, we just have to just keep drawing it. So we have this, we have this, so we have the x to be here, which represents the age, and we have the frequency to be here. So we have 15 to 20, we have 21 to 26. So let's quickly rush through this. So the next step is for us to get the necessary details required to get the mean absolute deviation. And if we take a closer look, we can see that we need to get the middle class of individual class. Now, like I said in the previous video, the formula for the middle class is actually equals to a plus b divided by 2, where a represents the lower class limit, b represents the upper class limit. So that means for class 15 to 20, it's going to be 15 plus 20 divided by 2. So that means that the middle class xm right here is going to be 15 plus 20 divided by 2. So 15 plus 20, that gives us 35, divided by 2, we have that to be equals to 17.5. So the next is 21 plus 26, that's 47, divided by 2, that gives us 23.5. So the next is 27 plus 32, and that gives us 59, divided by 2, that gives us 29.5, and we do the rest. So now that we've gotten the middle class for each of the classes, the next step is for us to get the mean, which is our x bar of our data set. This is the mean right here. So the formula for getting the mean is going to be x bar is actually going to be equal to summation fxm divided by summation f. So we need to get a space for fxm also. So we have fxm. So 15 times 17.5, that gives us 262.5. 12 times 23.5, that gives us 282. 7 times 29.5, so that gives us 206.5. We have 35 times 18, 35.5 rather, times 18, we have that to be 639. We have 9 times 41.5, we have this to be 373.5. And then we have 6 times 47.5, and that gives us 285. So let's sum everything we have right here to give us the mean. So that's 262.5 plus 282 plus 206.5 plus 639 plus 373.5 plus 285.5, and that gives us 2049 divided by, so the frequency is let's sum the frequency rather. So we have 15 plus 12 plus 7 plus 18 plus 9 plus 6, and that gives us 67. So we have 2049 divided by 67, and that gives us the value of the mean is 30.58. So the value of the mean is actually equals to 30.58. So this is 30.58. So the next step is for us to get the modulus of the mean subtracted from each of the middle class. So we have the modulus sign right here. So we have xmi minus x bar, and that simply implies that for any negative sign we have, it becomes positive. So 17.5 minus 30.58, that becomes minus 13.08, but we have a modulus sign right here, so it becomes 13.08. So we have 23.5 minus 30.58, that is a minus 7.08, but it becomes positive, so we have a 7.08. We have 29.5 minus 30.58, that is going to be 1.08. We also have 35.5 minus 30.58, and that's going to be 4.92. We have 41.5 minus 30.58. We have this to be 10.92, and then we have 47.5 minus 30.58. And that's going to be 16.92. So the next step is for us to multiply the frequency with the modulus of the deviations. So we have f into the modulus and rather xmi minus x bar. So that's going to be 15 times 13.08, and that is 196.2. 12 times 7.08, and that is going to be 84.96. 7 times 1.08, and that is going to be 7.56. We have 18 times 4.92, and that is going to be 88.56. We have 9 times 10.92, and that is going to be equals to 98.28. And then we have 6 times 16.92, and that's going to be 101.52. So when we sum all of this right here, we have 196.2 plus 84.96 plus 7.56 plus 88.56 plus 98.28 plus 101.52, and we have our answer to be 577.08. So that means that we are saying that the mean absolute deviation is going to be equals to 577.08 divided by, so the sum of frequencies is actually 67. So when we do the math, 577.08 divided by 67, and that gives us 8.61. So the mean absolute deviation of our data set is actually equals to 8.61 to 2 decimal place. So if you actually gain something from this class and you also enjoy the class, I would really appreciate if you can subscribe to this YouTube channel and like the video, and also turn on your notifications so that you can get notified when I release new video, which I do at least 2 times in a week. If you have any question regarding what we just solved, I would really appreciate, I'll be willing to help. So just send your questions in the comment section and I'm going to definitely attend to them. Thanks for making it to the end of this video, and we'll see you in the next one. Bye for now.